Hello everyone. This video would focus on compound interest, and this is the first part. In this part, we're going to solve for A, which is referred to as the total amount, which includes the previous interest earned. Before we dive into this example that we have right here, let's go over the formula for compound interest. Please remember that compound interest is defined as the addition of interest to the principal sum of a loan or deposit. In other words, compound interest is interest on interest. It is the result of reinvesting interest rather than paying it out, so the interest in the next period is then earned on the principal sum plus previously accumulated interest. In other words, it is an interest on top of the interest. So the formula for compound interest is A equals P, quantity 1 plus R over N raised to the power NT, where our A is referred to as the total amount, including the previous interest earned. P is the principal. R is the interest rate. This has to be expressed in decimal. N here is the number of times interest is compounded per unit T, and T here is the time. Please remember that the value of N will be based on the following. So if it is compounded yearly, our N is 1. If it is compounded semi-annually, the N is 2. Quarterly, the N is 4. If it is compounded monthly, the N is 12. And if it's compounded weekly, it's going to be 52. And daily, it's going to be 365. Okay, going back to the example that we have here, Jeremiah invests $4,750 in a retirement account that has a fixed annual interest of 2.7% compounded annually. What will be the account balance after 25 years? There are steps that we need to follow in order that we can solve problems involving compound interest. The first step is to write the given. So I'm just going to write all the given values right here. So we're going to start with 4,750. That's the initial amount that is deposited in this account. So we are talking about the principal. So P is $4,750. We also have another given right here, which is 2.7%. This is referred to as the rate. So rate is 2.7%. Now, please remember that rate has to be in decimal. We can change 2.7% to decimal by dividing this by 100. So this would come out 2.7 over 100. And so we can go ahead and say that if we use our calculator on this, the value would be 0.027. This is the value that we use in the formula and not 2.7. Another given that we have right here, it says that it is compounded annually. So this is our N value is actually 1. And then we also have another given right here, which is 25 years. And this is the time T. So I'm just going to write T is 25 years. And then the one that is missing here is what will be the account balance. That would be the amount in the account after 25 years. So that is A is missing. So I'm just going to go ahead and write question mark for the A. And so from here, we go ahead and move on to the second step. The second step is to plug in the values to the formula and solve for the missing variable. So I'm just going to go ahead and label this as S2. So again, the formula for compound interest is okay, so we plug the values in. So we start with the principal, which is 4,750. So I'm going to write that down here. So 4,750 times, that's going to be 1 plus. This is our R value, which is 0.027 over our N is 1. And then we have our N again is 1, and then times the time is 25. So that is 1 times 25. So that we go ahead and simplify this. Remember that 0.027 divided by 1 is just 0.027, and we're going to add it to 1. And then when we multiply 1 times 25, it's going to come out 25. So this equation would come out Okay, so we're going to use calculator to determine the value for this. So if we are using the blue calculator right here, this is how we set it up. So we're going to start with 4,750, then parentheses. Then we type in this 1.027, and then exponent. For this calculator, our exponent is this tab that we have right here, the one that is having an arrow up. Then we click this, and then we hit this, and then we put the 25 in, and then hit equals, and the value for that is 9,246 and 2 cents. So this is the balance in the account after 25 years. Okay, now let's use the TI-84 to see if the values would be the same. Again, I'm showing you the possible calculators that you can use. So we can put in these values that we have here. So 4,750 parentheses, that's 1.027. And then close parentheses. Again, the exponent for this calculator is still this arrow up that we have here, which would be 25. So it's set up exactly how it looks on this work that we have down here. So if we hit equals, they're going to be the same, 9,246.02. I rounded it off because after the 1 is 7, it's more than 5. So this comes out 2. So that would be 9,246.02 or 2 cents. Or you can use the Desmos calculator to determine the value for this. So you can see on the screen the Desmos calculator. So all we need to do is to type this values in, 4,750 parentheses 1.027 parentheses, and then we hit the exponent, and that would be 25, and the value is still the same, 9,246.02. At this time, I would encourage you to pause this video and try this problem out on your own, and when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, there are steps that we need to follow in order that we can solve problems involving compound interest. The first step is to write the given. So I'm just going to write the given right here, which is our step 1. So in this problem, it says that Cyril invests $6,500 in an account with a fixed annual interest rate of 3%, compounded quarterly. Determine the account balance after 8 years. So the given here would be So what I did was I listed all the given values that we have here. So this is the principal, that's 6,500. And then the rate, it says here that it's 3%. And then we are going to change this to decimal. We're just dividing this by 100, and that is 0.03. Our N here is 4 because it says compounded quarterly. So that would be 4. And then we are supposed to determine the account balance. That would be the A. And then the time is 8 years. And we're now ready to move on to the second step. The second step states that we're supposed to plug the values into the formula and solve for the missing variable. So I'm just going to label this as S2 right here. So I'm going to plug these values into the formula. Okay, so what I did at this point was I divided 0.03 divided by 4. That came out to be 0.0075. We're not rounding off. We copy everything. And then we have 4 times 8 because the N was 4. And then the time was 8. So 4 times 8 is 32. So that we can go ahead and add these two together. So that would be 6,500. And then this is 1.0075 to the power 32. And then using calculator, we should be able to get the value for these two and multiply it together. Remember, this is an exponent. So the final answer for this would be 8,000 8,255.72 or 8,255 and 72 cents. So this is the balance in the account after 8 years. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, there are steps that we need to follow in order that we can solve this kind of problem here. The first step is to write the given. So I'm just gonna label this as S1, that's first step, and I'm gonna write all the given here. Okay, so based on this problem, Brian invests 8,000 in a savings account that offers fixed annual interest rate of 2.56% compounded monthly. What will be the account and the balance after 10 years? So what I did was I got the 8,000 as the principal. Then the rate here, it says that it's 2.56%. So I need to change that to decimal. And then it's compounded monthly. So the N is 12. And then the time here is 10 years. And we're looking for the amount in the account after 10 years. So we're missing the A. So we're now ready to move on to the second step. The second step is to plug in the values of the formula and solve for the missing variable. So then we can go ahead and label this as S2 and we plug the values in. Okay, at this point, what I did was I multiplied the 12 and 10, that gives me 120, and then I divided the 0.0256 divided by 12, and this is the value right here. We're not rounding off, we just copy everything, and so we can go ahead and add these two together and solve for A. Okay, so after doing the math, the balance in the account would be 10,331 and 20 cents, and that is after 10 years. Did you get the same answer as this? Good, perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!